Moving on to a third question. Show that if the diagonals of quadrilateral bisect each other at right angles, then it is a rhombus. Now moving on to solution. Let us note down the given information. He says that diagonals of a quadrilateral bisect each other at right angles. So let us consider a quadrilateral ABCD in which the diagonals AC and BD bisect each other perpendicularly at some O. So let us note down the given information that ABCD is a quadrilateral, and as AC bisects BD perpendicularly, we can say AO is equal to OC and also BO is equal to OD, and angle AOB is equal to angle COD is equal to angle BOC is equal to angle AOB is equal to 90 degrees. Here what we require to prove is ABCD is a rhombus. We know the properties of rhombus, that in rhombus the diagonals bisect each other perpendicularly and all the sides will be equal. Here initially the condition is given that diagonals bisect each other perpendicularly. In etc. we need to prove that all the sides are equal, that is AB is equal to BC is equal to CD is equal to DA. Now moving on to the proof. Now in order to prove this, let us consider two triangles, that is triangle COD and triangle AOB. In these two triangles we can say angle COD is equal to angle AOB is equal to 90 degrees, which is given, and he also given that OA is equal to OC or AO is equal to OC as diagonals bisect each other perpendicularly, and also we can say OB will be equal to OD from the given. From SAS property, as in triangle COD and triangle AOB, two sides and one angle is equal, we can say they both are congruent. So by SAS property of congruency, we can say triangle AOB is congruent to triangle COD, and we know that when two triangles are congruent, then their corresponding sides will be equal. So here the corresponding sides AB can be equated to CD. Now as we got AB is equal to CD, let us name it as equation number 1, and then now let us consider both the triangles, triangle AOD and triangle COD. In these two triangles, let us note down the similarities. Here angle AOD is equal to angle COD is equal to 90 degrees, we know that, and OD is equal to OD since it is a common side for both the triangles. OA is equal to OC as BD perpendicularly bisects OC, as BD perpendicularly bisects AC. So here one angle and two sides of the triangle AOD and COD are correspondingly equal, we can say triangle AOD is congruent to triangle COD. When two triangles are congruent, then their corresponding sides and corresponding angles can be equated. So here let us equate AD is equal to CD. Let us name it as equation number 2. Now let us consider triangle COD and triangle BOC. In this, angle COD is equal to angle BOC is equal to 90 degrees, and OC is equal to OC since it is a common side for both the triangles, and BO will be equal to DO as AC bisects BD perpendicularly. So here, as in two triangles, the corresponding angle and two corresponding sides are equal, we can say by SAS congruence rule, triangle COD is congruent to triangle BOC. Now, when two triangles are congruent, we can say their corresponding sides and angles will be equal. So here the corresponding sides CD can be equated to BC. Let it name it as equation number 3. Now, from 1, 2 and 3rd equations, we can say every side is equal to CD, and so we can say AB is equal to BC is equal to CD is equal to DA. Here, initially from the given, we know that diagonals of the quadrilateral bisect each other perpendicularly and all the sides are equal. So finally we can say that ABCD is a rhombus. That is what the proof required for us.